Solar system is weird. There are a lot of things that might seem anomalous to us.
For instance, the famous Saturn's hexagon, or solar corona, which is many times hotter than the Sun's surface. But there are also some anomalies which are not that popular.
One of them is a mysterious equatorial ridge on Iapetus, moon of Saturn. So let's talk about its weird properties and some theories how it could have formed. My name is Andrei, and this is Cosmos Elementary.
It's hard not to notice this thing. That is the equatorial ridge on Iapetus, a giant mountain range situated almost precisely at the equator. At a first glance, it looks so unnatural that it's weird that there isn't a conspiracy theory that it is some kind of a wall created by an alien civilization.
Probably shouldn't have said that.
No known large enough body in the solar system has anything even remotely resembling this ridge.
Actually, it's not the only strange feature of Iapetus. It's frequently compared to
a walnut because of the ridge, to a Death Star because of a giant crater, to the yin and yang symbol because of its color dichotomy. Its two hemispheres have drastically different colors. Just like Earth's moon and most of major moons in the solar system, Iapetus is tidally locked, which means its same side always faces Saturn. The leading hemisphere is almost as dark as coal, while the opposite side is about as light as snow.
Another weird feature of the moon is its shape. It actually might have something to do with the ridge itself. So the moon is flattened, which on its own shouldn't be surprising. No spinning object in the universe is a perfect sphere.
The closest you get is with neutron stars, and even they are not perfect. Our Sun is a bit oblate, as is our Earth. Its polar radius is some 20 kilometers shorter than the equatorial one. Probably the most prominent example in our solar system is Haumea, a dwarf planet that looks like this because it spins so fast that it completes one rotation only in 4 hours.
So what's so special about Iapetus flattening?
Its polar radius is 34 kilometers shorter,
which doesn't seem that crazy.
But then Iapetus is way smaller than Earth, whereas in kilometers it's not that of a drastic difference. Actually, Earth has polar flattening of about 0.3%, while for Iapetus it's 4.5%. But still we have Haumea, so what's wrong with Iapetus? The thing is, the faster a body spins, the more it gets flattened.
Iapetus is flattened a lot, but it is spinning very slowly.
At this level of flattening, Iapetus has to be spinning as fast as one rotation in 16 hours, but in reality it's spinning 120 times slower and it completes one rotation in 79 Earth days. How is that possible?
There actually might be a link to the formation of the ridge.
I've already mentioned the ridge is situated almost precisely at the equator. But it's actually not a continuous ring, it covers about 75% of the equator. The ridge covers basically all of the darker hemisphere, while on the bright hemisphere it's more fragmented. The ridge is about 200 kilometers or 124 miles wide and can be up to 13 or to 20 kilometers tall, relative to surrounding regions. That means it's one of the tallest geological features in the solar system. And because the moon itself is relatively small, a structure that tall is very pronounced when the moon is viewed like this. It's about 3% of the body's radius. Also, the ridge is quite massive. It contains about 0.1% of the moon's total mass. By the way, there are no other major geological features on Iapetus besides the ridge and craters. There are several ideas how this weird feature could have formed.
Many groups of scientists have their own theories. There are two broad categories. The ridge could have formed due to some internal processes in the moon itself, or something might have caused its formation from the outside.
I've basically already started talking about the internal or endogenic reasons. Remember an unusual flattened shape. It tells us that most likely in the past Iapetus was spinning much faster. Due to tidal interactions with Saturn, Iapetus' rotation had been gradually slowing down until it became tidally locked. And if it had cooled down quickly enough, its flattened shape could have been frozen in.
So many theories involve the spinning and cooling of the moon. Because of those factors, its icy crust could have been deformed.
A contracting body can have thrust faults forming on its surface. The problem is that they have to form not along the equator, but rather in a perpendicular direction, and that doesn't really agree with what we see. Also, this doesn't explain why we don't see some ridges anywhere else but the equator, and why Iapetus hasn't got other geological features similar to what we see on Europa and Ganymede.
Some studies claim that those features might depend on different thickness of the crust at different latitudes, and the spinning can cause similar formations. There's one more idea based on the spinning of the Moon.
This is a visualization of a binary asteroid 1999 KW4. Kinda resembles something. And these are actual radar images of the system. And this is a 3D model based on radar observations. It's hard to miss this. This ridge also follows the equator. Looks a lot like Iapetus's ridge. That's why some scientists drew parallels between these two objects. Why does the asteroid have such a shape? Its rotation velocity is almost critical, which means that if it rotated just a little faster, gravity would lose two outward forces and it would fall apart. Because of nearly critical rotation, matter can accumulate on the equator. We know that Iapetus used to rotate much faster. Perhaps it too had a near critical rotation. The problem here is that a small asteroid and a large moon have different properties. That asteroid is basically a rubble pile, a bunch of pieces held together by gravity. In this case, a ridge can actually form because of fast rotation. But Iapetus is not a rubble pile. Even if it were spinning at a near-critical spin rate, it would probably have a shape of a triaxial ellipsoid, which means it would have three axes of a different length. This is exactly the shape of Haumea, which is probably spinning at a near-critical rate.
Another possible reason is convection.
It could have had two active convection cells that pushed on the crust at the equator.
There are several ideas how the convection might have worked.
Tidal heating due to tidal interaction with Saturn. Additional heat could come from a major collision with a large body. Also, some amount of ammonia could prevent the insides of the Moon from freezing, so it might not even need additional heat.
Some models that took convection into account managed to recreate the ridge, but it turned out to be not as tall and narrow.
Some scientists mention cryovolcanism. Matter could have risen to the surface, freeze, and formed the ridge. But again, there is a question of why only at the equator. Partially, it can be explained by temperature variation. Because of higher temperatures at the equator, ice could have melted, at least to some extent.
Some models account for multiple factors: convection, melting, cryovolcanism. So those were internal factors, and now let's talk about the external ones.
Among minor moons of Saturn, you can find these weirdos: Pan and Atlas, bodies shaped a bit like ravioli. Authors of a 2018 study who used Cassini data and computer modeling concluded that such a shape could occur in head-on collisions of two bodies. Something similar, but on a larger scale, could have happened to Iapetus as well. On the lower image you can see a simulation, and it has a similar ridge.
Probably one of the most popular scenarios deals with rings.
The idea is that Iapetus could have had its own system of rings, and the rings basically fell down to the surface, forming the ridge. This hypothesis has some advantages because it can explain some of the ridge's unique properties. For instance, it might answer the question why the ridge is almost exactly on the equator. Saturn's rings are also aligned with its equator.
How the rings themselves formed is up to debate. They could have formed from the same leftover material Proto-Iapetus formed from.
Rings could also form after a large body collided with Iapetus and a lot of material was blasted out to the orbit. But what happened to the rings after that? Again, there are several ideas.
Also, submoons or moons might have been involved.
By the way, I have a whole separate video on submoons.
Can you imagine that's where it could have actually existed?
Another possibility is that a submoon might have been a captured object. Also, both rings and a submoon could have formed, and the submoon pushed the material down to Iapetus' surface with its gravity. Or a submoon could have formed similarly to how our own moon formed in the collision debris in the Earth's orbit. And after getting too close to Iapetus, the submoon was torn apart by tidal forces, rings appeared, and those fragments then fell down and formed the ridge. There are studies where scientists modeled how material raining down to the surface could form the ridge. And according to those articles, it is possible if the material collided with the surface at low velocities and angles of up to 10 degrees. And yet there is still a question, why can't we see similar formations on other large moons?
Why don't any major moons currently have rings or their own moons, while dwarf planets and even some asteroids do have them?
There can be multiple reasons, but one of the main ones is the following. Dwarf planets and asteroids don't have in close proximity large massive planets that dominate gravitationally and destabilize orbits of submoons, so those objects can in fact keep their moons and rings. Iapetus in turn is quite far from its planet, so it has a pretty large zone of its own gravitational influence. It's several times larger than for most moons. Only a couple of moons are thought to be able to form equatorial ridges this way. It's Oberon, the moon of Uranus, and Iapetus. But even if they could, it doesn't mean that they will form such structures.
But for now, these are the theories.
We have very limited data, and most of it comes from one spacecraft, Cassini. This is, by the way, a cool animation of the ridge made from Cassini images. In the end, you can see some lighter surface appear. One of the ways to check those theories is to study Iapetus's craters. Depending on how the ridge was formed, it can have different age. If it had formed quickly after the moon's formation, it has to be almost as old and heavily cratered as the rest of the moon. If it had formed later, it would have different cratering. Authors of this article studied more than 7,700 craters and concluded that it's more likely that the ridge is substantially younger than the rest of the surface, and that the ridge is the product of accretion of rings. But as it usually goes, we need more studies and images of better resolution to be more sure.
Links to all of the sources are down below in the description, and if you enjoyed the video, leave a like, comment and subscribe. Bye!